how to describe XRD graphs and how to describe SEM graphs. These two techniques, the X-ray diffraction analysis and the scanning electron microscopy analysis, must support each other. The results, the finding from these techniques must follow each other, must support each other. So let's get started. This is the XRD graph for two different samples. The first one is basically the control sample. Control mean it is in pure form, it is in pristine form, there is no additional amount added. We can see from SEM, this is basically the surface morphology of the control film here. Now what happened when we add this 60IC4F to the control film? This may be an additional amount in the form of solid, in the form of solution, in the form of solvent. So we want to see what changes occurring in the structure of the material and what change is happening to the surface morphology of the material. So when we want to see changes in the structure, so for that we use XRD, and we want to see changes to the surface morphology, so for that we use SEM here. Let's get started. For the control film, here we have two main peaks here. One is lying here on x-axis and 15, 14 to theta, and one is lying here and 28 here. Now what happened when we add this thing? So we get the similar peaks here. So this means that this material does not change the crystal structure of the material. There is no variation in the structure of the material. The structure remains same. But what basically happened? It improved the crystallinity of the material. How? Because we got the intensity here which is larger than the pristine one. The intensity basically increases here. So this means the crystallinity improved, and it is the clear indications. The peak position does not change. This shows that the crystal structure remains same. For example, if initial it was BCC, so this will be the BCC. If initial it was the hexagonal shape, it will be the hexagonal shape. If initially it was the simple cube, it will be the simple cube. This means the crystal structure remains same, but the crystallinity improved. And how we know? We know from the peak intensity. When we get enlarged, when we see increase in peak intensity, this means the crystallinity increases here. Let's see how to write about this XRD in the research paper. So the XRD analysis or method was used or was conducted to investigate. So you can write here to explore the control and this treated perovskite crystal structure. You can replace this according to your samples here, right? Is shown in figure XA. This may be 5A or 2A. Both films showed apparent diffraction pattern corresponding to 100 and 200, the main peaks here, right? But compared to the pristine one, the control one, the treated one basically shows improved intensity, and this basically indicating or revealing that it is improved in crystallinity, but without inducing structure changes. You see here, this is the most important one. How we know that there is no structural changes? We know from the peak positions, because the peak position remain same. There is no change in the peak position, so we can clearly see that the crystal structure remains same, right? Now let's come to the scanning electron microscopy. As I mentioned there, always take the magnification same if you want to compare to. Otherwise, people will not trust. The reviewer will raise questions that yours magnification are different. So we can see here now clearly this is 400. So there is no grain of 400 nanometer. I can guess here. Yeah, it's very easy because no grain is there comparable to this bar here. This means that all grain are basically, if I look this one may be half of this bar. This may be 200 something. So we can see that in the control one we have smaller grains, while in the treated one here we have improved in grain size. We can see where all the grain size increases. So this is one indication. We can write about the grain. One thing here, we can also compare both surfaces, because we can see that both surfaces are compact in uniform here. we can see that, look, this is the compact here, mean there are no holes or something. So we can talk about the uniformity, the compactness of the surface, and we can write about the grain size. And how we can compare? We can simply see that the grain size improved significantly upon addition of this to the perovskite film here. So scanning electron microscopy was performed to explore, you can write to investigate, to study the effects of this treatment on the perovskite surface morphology. Yes, is seen both the control and modified perovskite, mean the treated film, showed homogeneous surface morphology. Yeah, homogeneous morphology. However, the average grain size of the film increased from 119 nanometer to 200 nanometer. This is how we interpret XRD and SEM analysis in the research paper. The data I took from the important paper. This is the paper I took the XRD data, and this paper is basically published in Nature Communication. This is the title of the paper by Jing Wang et al. In 2020, and this paper is published under Common License 4.0, and this is the link to the license. And the SEM graph I just took from the supplementary information of that paper.